So here we're asked to consider the curve y is equal to 3x squared plus 4x minus 1, and we need to find the average value of the curve between x is equal to 1 and x is equal to 3. So there's an equation that we can use for finding the average value of a function, and that is y with the little hat on the top. All right, this is the actual average value that we're going to try and compute, and it's equal to 1 over b minus a times the integral from a to b of our function integrated with respect to x. So essentially what this equation is doing is figuring out the total area under the curve between a and b, which is this part here, and then we're dividing that by the length of the domain. So b minus a is going to be the length that we're looking between, and in this case b is going to be the bigger value, all right, which is the 3, and a is going to be the smaller one, which is a. Alright, so let's substitute into our equation. So we're going to get 1 over 3 minus 1, and we're integrating it from 1 to 3. Y is this function that we've been given, and we're integrating it with respect to x. Alright, so this here can simplify to just be 1 over 2, and now we probably want to actually integrate what's inside the integral symbol. So I'll pop a square bracket here and then we'll actually do it. So it's just going to be the power rule that we have to apply. So 3 stays out the front, add 1 to the power, so the 2 goes to 3, and divide by the new power, which is 3. So for the next one, remember this is x to the 1, so we're going to get the 4 out the front, add 1 to the power, so it goes to 2, and divide by the new power. So the last one, remember you can write in here, this is equivalent to x to the power of 0. Anything to the power of 0 is 1. So it's just the equivalent of multiplying by 1, which does nothing. So we leave our 1 out the front and we add 1 to the power here, which would be x to the 1, divide by the new power, which is 1. So that's all going to kind of cancel out. And we'll carry across our bounds. So we're still looking between 1 and 3 for x. So we can do a little bit of simplification, so I'll leave the half out the front. What we're going to have here is the 3 on the top and the 3 on the bottom cancel. We're going to get 4 divided by 2, it's going to leave us just with 2. And all of this, the 1s can all kind of drop away, and we're just left with the x on its own. And we're still looking at evaluating this from 1 to 3. So let's go ahead now and actually substitute in our bounds. So we always start with the bigger one. And we've still got this half out the front, so don't forget it. So subbing in this first 3, we're going to get 3 to the 3, 2 times 3 to the 2, minus 3. So I'll bracket that off. And then we take away what happens when we sub in the 1. So we're going to get 1 to the 3 plus 2 by 1 squared minus 1. All right, and making sure we keep these brackets in here, so that everything that falls out of our integration is times by that half out the front. So let's now simplify this down. So 3 cubed is 27. We're going to get 2 times 3 squared is 9, so that's 18. And then here 1 cubed is just 1, and this is going to be 2 times 1, which is 2, and we've got our minus 1 on the end. Alright, so keeping on going, I'm going to get rid of the bracket, so this can be written as 27 plus 18 minus 3. And here we've got, well, it's a 1 and a minus 1, so they're going to end up cancelling with each other, and we're just going to have the minus 2 that pops out on the end. Alright, so inside the bracket here, 27 plus 18 minus 3 minus 2, this all simplifies to the number 40. And then a half times 40 is just going to leave us with 20 for the answer. So that means that the average value of this function across the domain of 1 to 3 is going to be equal to 20. Now, if we want, we can actually compare this to Wolfram Alpha if we have access to it. So what I've done is plotted the function and I've picked a domain just to kind of zoom in to where we're interested. So remember, we were looking at the average value between x is 1 and x is 3, so this kind of section in here. So what we calculated was the average value through this part was equal to 20, and that looks kind of reasonable, okay? So obviously this little bit here, if it's going to have the same area as if it got inserted down here, and thus we've got that average going through the 20 mark. So that's pretty much all there is for this video.